Hey guys, greetings. Welcome to my dark and lonely office. I'm not entirely lonely. Covey? Hey. Hey, wanna say hi? Come here. So, not entirely lonely. Covey says hi. Okay, go lay down. I hope everybody's staying safe and staying inside. It's our crazy times that we live in. I should start by saying I despise taking videos and photos of myself, so this has proven very difficult, and hopefully we'll be okay. So logistics to get out of the way, house cleaning, let's see. Those of you in writing intensive, this coming Monday, the 6th, you guys will have your number 3 peer review due. Repeat, if you're in writing intensive, peer review number 3 is due on Monday. Other house cleaning, for those of you keeping score on your calendars, upcoming things to keep in mind aside from the review that I just mentioned. Quiz 4 was this week. We won't have another quiz until the week of April 13, so next week will be off. The following week will be quiz number 5. That will be back to normal, I'm assuming by then, where it will open on Thursday or Friday and you'll have through the weekend to take it, unlike this week's quiz, which went up late and just closed, or is closing tomorrow, I think Friday morning, which this video will be going up Friday afternoon. Let's see. The 2 talks that are scheduled for next week are Dr. Haynes talking about endemism and evolutionary diversity in Hawaiian insects, and Dr. Plenovich talking about restoration on Pacific Islands, a couple case studies. I'm not sure if those will stay, but that's what's currently scheduled. So just to review that one more time, going forward, writing intensive, your peer review number 3 is due on Monday, this coming Monday the 6th. For discussions this coming week, we have an outdoor activity scheduled, and another one of the environmental assessment weeks. We had a geology field trip also on the schedule, but that obviously will not be happening. So I will be game planning and deciding between a few different things to do for you folks' discussion for this week. I would count on it being up midweek. I'll produce another video, some sort of environmental assessment outdoor activity. Then the quiz 5 will open probably Thursday or Friday of this week. So I guess that's it for house cleaning. One other note, you guys have been learning about fungi, had the nice video from Dr. Amend highlighting incredible diversity of the fungal kingdom and evolution and diversity and ecology of fungi in Hawaii. That reminded me, I wanted to tell you folks, it has just, like in the past week, come available to download. And that is a wonderful new documentary by Paul Stamets called Fantastic Fungi. Check it out. I think you can rent it $3. Totally worth it. Really great documentary. So while you're at home on quarantine, you can further expand your fungal knowledge and rent Fantastic Fungi. It's a great follow-up to Dr. Amend's lecture. So now to get to the quiz. Sorry about the issues we had. I've been having problems with my phone last week, and now with my computer at home. So you guys got a very abridged question pool. Not that you would have noticed, because you folks only get a handful of randomized questions anyway, but they were chosen from a smaller pool, about half the size than we normally would do. So what I've done is just print out all of the questions that you guys had, and I'm just going to run through all of them. So that will cover all of the information that anybody had on a quiz, and then maybe just a couple other associated bits of information to go over that would have been on quiz but weren't. And that's about all that we'll do. So this should be, a little brief. We're usually talking back and forth, so I will not be talking for 40 minutes at you, don't worry. First question was from Dr. Eligato's lecture. It asked about describing the legend of Lehoula, and who was he, and why was he famous and well known. So he had like a supernatural understanding of fish, right? He was the head fisherman during this time of famine. He built the first fish pond that really revolutionized the way that farming, aquaculture, fish production was done here in Hawaii. He did that, I believe, on the east side of Maui, and it then spread throughout the state afterwards. The next question was, according to Dr. Aligato's lecture, what can we learn from studying fish ponds? And there's a lot of things that we can learn from them, but the specifics that she outlined were that you can really understand the environmental impact of episodic events like a flash flooding, storm, a hurricane, and how that influences coastal areas and things like a fish pond, and how it influences microbial activity in those areas. It can aid in determining the effects of climate change over time, and how these processes and events all interact under the aspect of climate change. And it also just, above and beyond all of those things I just laid out, it helps to create a baseline for land use change, to kind of see that this is where we're at, and when these things happen over time, these are how it impacts things, and it's a really nice baseline to have. The next question, staying with fish ponds, was related again. What happens to the microbial communities in fish ponds when there is a big storm event? So I would be asking you guys, what do you think? What would happen? So we've got a lot of rain, say, hitting the mountains, the land, causing a lot of runoff. All of that runoff is going down to the shore, making its way out to the ocean. And so if we've got a fish pond set up in that intertidal coastal area, how is that going to be impacted by some chance natural event like that? And as you might think, all of those things from the land, good, bad, and otherwise, are getting washed, getting flushed out. So there is like a major increase in microbial diversity. All of these terrestrial and montane things getting washed downstream and out to sea. And there's, with that new incursion of diversity of microbes, you're seeing a huge percentage of these terrestrial microbes come into this marine enclosure. So that would be the main results of an event like that. Getting into Dr. Amen's lecture on fungi. A native Hawaiian plant species grown in sterile greenhouse conditions after or where endophytic fungi are not present have a high mortality rate shortly after being planted in the field, while seedlings that were grown in situ on the site out there had a much higher survival rate. This provides evidence that a possible blank type of association exists between the plant and the endophytic fungi. So, first, endophytic fungi, what is that? That is different fungal microorganisms that live internally in plants, right? They're not just only associated with plant leaves outside or the roots under the ground. There are fungal organisms inside all of these plants, inside the roots, inside the leaves, just like there are fungal organisms inside of us. This scenario that they've put forth where some plants that are grown in a greenhouse that don't have fungi are put into the field and they die, and the plants that were already out there presumably and are inoculated with some endophytic fungi don't die. So what does that say? That says that there is a mutualistic relationship between these fungi, likely. The other choices were saprotrophic, so a decomposing type of situation, pathogenic, where that would be where the fungi is actually a pathogen on the plant and causing it problems. Or the last option was commensalistic. So a commensal relationship would be like it doesn't benefit or cause harm to either one. So again, the choices are, is it a mutualism? Is it saprotrophic? Is it pathogenic? Or is it commensalistic? So a mutualistic relationship makes the most sense for sure out of all of these choices. And we know that majority of the time, the interaction between plants and fungal organisms is a mutualism. Let's see. Kavi, you stay over here. Let's see, the next question. According to Dr. Amen's lecture, about how many fungal species have been described by science? So, assuming you guys all watched that, you'll recall at the beginning he had a researcher who had put forth different numbers. I think the first one was in 1991. He had guessed that there must have been 1.5 million fungal species on Earth. He guessed that, I think, based on the fact that for every plant where he lived in Britain, there was a half dozen fungal species. And then later that year, in the same year, he revised his guess, and he said, I kind of forgot about insects. And so maybe there's a half dozen for insects as well. So he doubled it and went up to about 3 million. I think it was about 15 years ago that there was another new guesstimate put forth. It was like about 5 million. And that's still thought to be extremely low. I think Dr. Amend ended up saying that they think that there's about 1 trillion species globally, if you count every avenue of fungal species, big fruiting body, basidiomycetes and ascomycetes, all the way down to mycorrhizal things and various pathogenic fungi all throughout the whole world. They estimate about 1 trillion. And I think they said there was 2 to 5% of the species on Earth they thought had been described. So all of that to say that the answer to the question, how many fungal species have actually been described, is 100,000. So they're guesstimating how many there are. and basing it on about how many have been described, but the number that have been described is about 100,000. According to Dr. Amen's lecture, what ecological roles do fungi fill in nature? So again, we just talked about some of that. They can be saprotrophs. Many have co-evolved to be mutualists with plants, like the mycorrhizal associations that we're finding in almost every single plant. There's one or numerous mycorrhizal relationships, and then the pathogenic fungal species as well. There are things that are saprotrophs and are living on living things, like digesting your fruit that you leave too long in the fruit bowl, or things like rapid ohia death. So those are pathogenic. There are just a huge number of these fungal diversity. But the ecological roles, are many, pretty much anything you could think of. According to Dr. Amen's lecture, there are blank species of mushrooms in Hawaii. And furthermore, does this estimate include microfungi? So the answer was 683. That has to do with mushrooms, things that make a big fruiting body to disperse their spores. But he had in the movie that in 1973 there was only 23 species known. 17 years later in 1990 there was just over 100. Today there's about 350, but if we include everything that had been added after things like bioblitzes at the Volcanoes National Park, where they tripled what was known in 48 hours, the estimate rises to 683. So starting at 20, going to 100, then to 350, and present day we're at 683. Again, that's what we know of. So if you extrapolate this out to how many fungal species that produce mushrooms are there in total, those that we know of that are documented and not, they estimated that it was probably between 1,000 and 2,800. And if you included all of the micro fungal organisms, that number grows by an order of magnitude, and it was 30,000. So I know that was confusing. To go over it again, according to the lecture, how many species of mushrooms are in Hawaii? So there's 683 described. Those are the ones that make some sort of visible fruiting body. But they estimate that there is between 1,100 and 2,800 that exist in Hawaii total, when we include those that have not yet been described. And if we then extrapolate out to include all of those species that make big fruiting bodies, and we can see, or not, the ones that are all mycorrhizal, under the ground, pathogenic, microscopic, we're at about 30,000 in all likelihood. Hopefully that made sense. And this estimate of 683 did not include microfungi, but these other ones I just mentioned do. In which fungal phylum do lichens form? So the choices were ascomycetes, basidiomycetes, zygomycetes, or algae. So it's obviously not algae, because that isn't a fungal phyla. So in which fungal phylum do lichens form? And they form in either of the first two. That is the ascomycetes and the basidiomycetes. And I was just going to mention this, but for those of you that it wasn't clear on one of the lectures, though it seemed extremely clear to me, or if you didn't have a chance to watch a lecture, or you didn't know this, or didn't understand, lichens are what kind of organism are they? They are a combination organism, a symbiosis of two things, right? So this next to last question, the lichen symbiosis is a mutualistic relationship between what and what? And the answer is fungi and algae. We've got the housing of a fungus with algae doing photosynthesis inside. So we've got a combo organism, photosynthetic algae inside the case of a fungus. Pretty cool. Many lichen-forming fungi